gravitational redshift. Anyone know about gravitational redshift? Okay, so note what will happen. If you have a star here, and that star is emitting light, it will start off as a very high frequency, but as it goes forward, its frequency will decrease as it goes away, because its speed will go down as it goes away. So when things are traveling towards you versus when things are traveling away from you. And that effect is called Doppler's effect. And that all is manifested in this very, very, very simple equation. So if it has a frequency, let's say f prime here, it will have a frequency f here as it goes away. Or vice versa. I can say if this is frequency f, this is frequency f prime as it goes away. So let's put some math to it. If suppose that the radius of this surface is r and its mass is, say, m, we know frequency f must be greater than f prime. Is that true? It'll start off with a high frequency. As it goes away, it's going away from it, so it's speeding down. Because photons cannot travel with any speed except for c, how does that speed decrease manifest itself? By decreasing its frequency, which means it changes color as it goes away. Which is why we know that the universe is expanding, because the light we are observing from the stars are shifted red. That's why we know they're going away from us. Cool. Okay, so let's put some math to it. What do we know about the gravity? What do we know about gravitational potential from intro 1? Do we know this? Yes? Or minus g m over r. What was the photon mass again, people? Note, I am using this equation. This equation is an equation that does not deal with waves. Notice that? This is a gravitational potential energy equation for both masses. Keep that in mind. It's very weird, but it's true. I'm using all of these equations, which are for two massive particles. Okay, so that basically means is I can rewrite potential energy as minus G M H F over RC squared. Then the total energy will become potential energy plus the quantum energy, or minus G M H F over RC squared plus, what is the quantum energy? HF, which I can rewrite as 1 minus GM over RC squared. Okay, so I'm going to call this equation 1. And then also, when we are very, very far away from the sun or the star, is it true that its gravitational force goes to 0? Which means I can rewrite this for far case as just HF. I'm going to call this equation 2. I'm going to call this HF prime. just to differentiate it. That's far, far away. However, I know that these two energies, conservation says that these two must be equal. Energy far must equal energy close, otherwise it won't work. So I can rewrite from 1 and 2, HF prime equals HF 1 minus GM over RC squared. May I cancel both H's? May I put this like this? F prime over, ooh, wrong color. F prime over F equals 1 minus GM over RC squared, or 1 minus F prime over F equals GM over RC squared. It's basic algebra, right? Or I can say F minus F prime divided by F equals GM over RC squared. And in textbooks, they usually write this as something called the relative frequency change as delta F over F minus GM over RC squared. And that implies that the photons reaching Earth will have lower frequencies than what they started with. So what is the lowest frequency that we visibly can see? Red. And that's why they're redshifted, because those are going away from us. If they were moving towards us, it would be blue shifted. Or a photon in the visible region of the electromagnetic spectrum will be shifted towards the red, and that is called gravitational redshift.